Hello everyone, today I have two UPS. The brand is FSP. The model that I have is FP series 600 volt ampere with 12 volt battery and IFP series 2000 volt ampere with 24 volt battery. FSP is good brand power supply, but I don't know much about FSP USB lineup. Both are line interactive. As I know, FP series only LED status and IFP series with LCD status. I buy IFP series because the price is relative same for 200 volt ampere. So why not? Of course the product already disassembly. But if you want to know, the product is like this. For FP series, every volt ampere rating have different feature. Like only one LED or dedicated 3 LED status with or without USB communication, pair with RG port surge protection, fan, input fuse model. For IFP series, every volt ampere rating have different feature, like with or without USB communication, pair with RG port surge protection, fan, input fuse model. Okay, let's start from transformer. I don't have idea what I need to tell. Okay, it's big, heavy and hot. And it's need to be because it's low frequency transformer. At the input we have 4 connection, 2 primary and 2 other tap, because it's auto transformer. At output we have 2 connection without center tap, and yeah, I love it. Because we need full bridge driver instead half bridge. More power we can get every cycle and more pricey. The difference between is size, because the one have bigger capacity. It's need multi-wire for efficiency. I don't know it can be called lead wire or not. It's to avoid skin effect from the thicker wire. Oh yeah, I need to replace the UPS because the secondary is blackening, is burning. The primary is white. Maybe next video I will try to recoil the transformer. Next we have main board. Let's see the difference between this board. The big one for bigger capacity, and here we have fan connector. I don't know if it's speed control or not, but the fan only turn on at battery mode. Of course the small one doesn't have. Okay, I love the active cooling, but let's more systematic. Start with talking difference between board from the primary. In here we have metal oxide varistor for surge current protection, but omitted at the small one. Next we have 2-pole main input relay, but it's omitted, so it's same like the small one. The small one doesn't have space for neutral and live. Next at secondary we have fuse, but it's omitted, so it's same like the small ones. So the battery is unprotected, but the main input have a fuse at the casing. It's disappointing for me. I pay more for this 2000 volt ampere. It's not cheap, but no fuse for the battery. Imagine if the MOSFET is shorted and the UPS is blown up. Next, in here we have buck converter that the small one doesn't have, maybe for driving 8 MOSFET. The last is they have serial communication port that the small one doesn't have in here for USB communication. For how this main board can work, let's start it. Okay, let's divide into 2 sections, the primary section and secondary section. First, at the PS input, we have metal oxide varistor for surge voltage protection. Next, we have X capacitor for filtering, and we have input relay. This relay is turned on only when the UPS in standby mode and online mode. Next, we have 2 pair relay for automatic voltage regulation. This two relay is controlling this auto transformer taps to adjust the output voltage for the UPS output and the battery charging input. Next we have one more relay. This is only for output of UPS. This relay only turn on in online mode and battery mode. In here we have output capacitor, X capacitor with in series with resistor, and this 3 pair resistor is for current detection. This detects the current from the output UPS. Next we have 8 pair of MOSFET, and this full bridge is bidirection, and it can control pulse width modulator by the microcontroller. And these two capacitor parallel with the battery. Next we have controlling component, but I don't know what I need to tell. But here we have buck converter, some capacitor, something for the microcontroller. We have buzzer, we have octocoupler, and here we have linear voltage regulator for the microcontroller and other. At the back we have my microcontroller, and I don't know it's for what. I don't know. And here the buck converter driver with diode. In here we have giant track for high current, and that's it. For the microcontroller we have MC9S08. This is 8-bit processor with 20 megahertz oscillator, have 16 flash kilobyte memory and 1 kilobyte RAM. And the brand is NXP. It's good. Okay, in here we have advanced analog circuit AS3224M. This is up amp, quad channel, and low power, and that's it. And next, in here we have Unisonic Technologies UC3844G PWM controller in current mode. I don't know. Yeah, you can read this, and this is the example in description. I don't know for what. And here that I guess it's buck converter, but surprisingly this is on semi inverting regulator buck boost converter. Whoa. I don't know for what. For maybe for driving the MOSFET maybe. But why we need inverting buck boost converter? I don't know. Okay, on semi MC34063AG, the model that I have. The output 3 volt into 40 volt. Yeah, 1.5 amp. Low frequency for me. Yeah, and that's it. Okay, the last we have, it's 78L05. Everybody know this is the linear regulator. I think this is for microcontroller, and other peripheral like LCD, buzzer, and anything. That's it. Okay, for the small one, we have the same, but some component is omitted. We only have the PWM controller and microcontroller is the same. We have a different voltage regulator, but yeah, it's the same. So we don't have the inverting buck boost converter and the op-amp in this big model. It's omitted. It's not omitted, but yeah, these don't have. As we know, this is the line interactive UPS. We have a transformer, auto transformer. At the primary, we have 2 input and 2 other taps. The output we have 2 output without center tap. When in online mode, so the UPS output is turned on and the battery charging, the main power input into here, the relay is connected, the IVR activated by condition, controlled by microcontroller of course, and this output relay is turned on. So this main input into transformer, and if FVR works, automatic voltage regulator works, the output is the same as input or this other 2 taps of transformer, step down or step up. And this secondary of transformer is charging connected to this full bridge driver, and this full bridge driver is controlling the voltage by doing pulse width modulation into these 2 positive and negative battery. And we have big capacitor parallel. If the UPS in standby mode, the main power input is coming into here, the relay input is turned on, the FVR relay works by condition, but this output UPS relay is turned off. But because this relay is turned on, the main input is going into the transformer, and the output transformer secondary going into this full bridge driver to charging the battery. But there's no voltage at the output of the UPS. When the UPS in battery mode, we have voltage from battery going into the UPS mainboard. It's controlled by this full bridge driver, and the output of full bridge driver is connected into the transformer, secondary of transformer. So at the primary transformer we have 200 volts depending on the model. I have the 200 volts model. In battery mode, this FVR is worked by the condition of the voltage battery, and this output relay is turned on, so we can get electricity from the UPS. But the input relay, the input UPS relay is turned off. Oh yeah, I think the FP and IFP have the same main boards, but divided into 2 model. The 12 volt battery and 24 volt battery. For the example, for IFP we have LCD status indicator, but in FP series we only get 3 LED indicator. And here we have switch, digital switch, that in the FP we have this switch on the display. This USB connection is optional if you have the higher model. We get it. The fuse I don't know, and the relay, the two-pole relay I don't know why it's omitted. For the 12-volt battery, we have LCD option or 3 LED or 1 LED option. This jumper control the LED output, and we have even here maybe, I don't know, it's the same. Yeah, and that's it. Maybe between volt and capacity, the difference may be on this transformer size and the MOSFET model, I think. Of course, the shunt resistor is different to detect the current, output current. Next, let's talking about component that only the bigger one have. And here we have fan from HSC, brushless fan, blah blah blah, 12 volt. Maybe the inverted buck bus converter for this fan, maybe. And it's have 0.2 amp rating, hydraulic bearing. Okay, that's good. This brand is good. HSC. Okay, and here we have USB communication and RG surge protection. The RG port surge protection only boring metal oxide varistor with diode. Okay, this is first time I see USB communication like this. It's interesting because from the microcontroller we control the octocoupler, so this section and this section is isolated. This chip is powered by the computer that's connected into this USB type B. This is the capacitor to turning these chips. And interestingly, this chip is Inotech IN 6005 8-bit microcontroller, but it's for USB general purpose application. Wow, I don't know the output communication signal like. Interesting. And this is the LCD display. We have switch, the LCD with touchscreen input, and here we have only LCD display driver. So this output LCD and touchscreen is controlled by main microcontroller. I like this. Interesting. Oh yeah, I have been modified this board to make the backlight is always turned on. Before we have BG transistor in here, but I've been jump the negative or cathode to make this backlight always turn on. Okay, this is the last question for you. Did anybody brave enough to plug input to output UPS? UPS and mobile phone power bank is very different device, right? This will blow up or not? Protected. Okay, I swear this is the last thing in this video. I have been observed how this UPS work between 600 volt amp and the 2000 volt amp. For the IFP 600 volt amp, what I can observe is not much. Around floating charge, 90% battery, we get under 50 degrees Celsius, around 10 watt. So the standby power is 10 watt. At 0.6 power factor, and the transformer is humming. Auto transformer for AVR works good. Transformer humming louder on battery mode, maybe because modified sine wave. With fluctuate load, the auto transformer tap change to adjust the output voltage. At battery mode, before low battery alarm, they change the auto transformer tap. After low battery shutdown, if we restart the UPS can start again. I think this is bad. It's not smart. From low battery turn off, we get 20 watt charge at 0.9 power factor with silent transformer hum. On-off button is hard button, but the signal processing is digital. The fuse is changeable. Not all model FP series FSP UPS have fuse. This is have, but changeable, not resetable. For the FP2000, what I can observe is around floating charge, 90% battery, we get under 50 degrees Celsius, around 20 watts. So the standby power is around 20 watt. At 0.6 power factor, the battery voltage is above 26 volts and the transformer humming. At 100% battery charge, the voltage is 29 volt. At 56% in battery mode, the auto transformer type relay changes from around under 220 volt to around under 230 volts. At 55%, low bat alarm turn on at the battery voltage under 24 volt. The display says 75% when UPS in low battery alarm. It's annoying for me. So the LCD status load and battery percent in 25% step is unusable. 25% step. Why? At 40% under 23 volt battery, the output UPS is under 220 volts. Under 30% battery, the battery is 22 volts and the voltage is under 220 volts. The display always turn on, but the backlight turn off after 10 seconds, like the UPS is die, except transformer humming. Only when in battery mode, backlight always on, and the humming louder because the signal is square wave. When the load fluctuates, like PWM controller appliance like laser printer at full load around 1100 watt in battery mode, output voltage and auto transformer tap relay goes crazy. The max voltage I have is 290 volts. I don't know the lower I can get. The fan is always turned off in online and standby mode, but always on at battery mode. I don't know about the variable fan speed. On and off power button is hard button, but the signal processing is digital. Fuse is resetable. I don't take observation at 50% battery charge, so I don't know about the temperature, watt, power factor. Body mounting not stable because the body is skew and crack. It's because shipping and very simple packaging. From USB communication, this UPS have 3 mode: line, standby and battery. From USB communication, we have detail load battery percentage at 1% step. From USB connection, we have same information like in LCD, but we have battery voltage and frequency information. The software is generic or universal. That's called view power. The UPS unable to restart after low battery turn off. That's good. It's smart. From low battery turn off, we get 90 watt charge at 0.9 power factor, and transformer is silent, not humming, and the LCD battery capacity jumped to 75%. It's annoying.